In this instruction video I will explain you how to use systems engineering for your collaborative design project. First, we define systems engineering. Then the 4 basic steps of the systems engineering method will be discussed. The relation to project management is shown. Different approaches are given. And finally, the relation with BIM is defined. There are many ways in which to define systems engineering. Here we use the following definition: the function of systems engineering is to guide the engineering of complex systems. A systems engineering method consists of 4 basic steps, starting from the client needs and ending with a solution. You can find more information about the client in the project assignment. The solution is the project design. The 4 basic steps are requirements analysis, functional definition, physical definition, and design validation. Here, the elements of the systems engineering method are displayed in a more detailed flow diagram. In the following slides I will discuss each step in more detail. The first step is requirement analysis, also named problem definition. You will collect information from the assignment document, but also from the internet and university library. You can search for similar projects and find out which requirements they define. Obviously you have also to fulfill requirements that follow from building codes and standards. You can collect information about the project site itself and its surroundings. Probably there are zoning plans and maps available, and you can collect statistical data about the urban environment. The second step is functional definition, also named functional analysis and allocation. When applying systems engineering in the domain of architecture, engineering, and construction, a function can be interpreted as a human activity that is accommodated by space. For instance, at the building level the functions living and sleeping. At the urban level we can specify functions such as parking and shopping. When possible, you must specify the floor area and space volume for a human activity. Later in the design process, functions can also take the meaning of a system function such as room heating or street lighting. For these system function you need to specify the required performance values, such as minimum temperature and lux. When you have developed a complete list of function requirements according to the client's wishes and needs, you can move on to the next step. The third step is physical definition, also named synthesis or physical analysis and allocation. The step is often considered the real design step. In the step you'll use computer design software for drawing models of buildings and for drawing maps of the urban environment. Use design software that is available from the university software library or that you can find on the internet. With the design software you specify the dimension of building spaces and the material properties of building element. In the map drawing software you specify the road infrastructure, the green space and the street furniture. The final step is design validation, also named verification and evaluation. In this step you will check if the functional definitions that you specified in the second step are filled by the physical definitions in the third step. In other words, you will check if your design actually fulfills the requirements that you stated earlier. If you have stated that your design should accommodate the activity sleeping, then you must check if indeed a sleeping room can be found in your building design. Similarly, if you stated that your design should accommodate parking, then you must check if your urban plan contains sufficient parking places. In the previous 4 steps I have briefly explained the systems engineering method. However, systems engineering is part of project management. Students that have followed courses in project management can use this knowledge in the collaborative design project. In literature you can find different systems engineering approaches. Some of them presented on this and the next slide. On the left you find the famous V model, showing the design process as a decomposition and integration process at different levels. At the left of the slide, you find a cyclic design model, showing that a design evolves from conceptual design to detailed design, through many design cycles. In the collaborative design project that design cycle typically will take 1 week. Every week you will execute the 4 systems engineering steps, but obviously the design will become more detailed and concrete in every design cycle. In this course you will apply systems engineering and building information modeling. The system engineering 4-step method is used to organize the design process. Building information modeling tools are used to create the design. With the BIM tools you implement a collaborative design monitoring system that allows you to track and trace every design change during the design project. So, to conclude, the function of systems engineering is to guide the engineering of complex systems. And having this structured process helps you dealing with the requirements in a complex project. Finally, if you are interested in systems engineering, you can download a copy of the Systems Engineering book from the university library. The book is useful during the design project to find practical tips, but also when writing your academic paper at the end of the course.